Then next we'll move on with the DHCP, DNS, FTP, and TFTP. What is DHCP? Dynamic Host Configuration Protocol. Okay. Dynamic Host Configuration Protocol. Why it is used? Used to dynamically assign the IP addresses to the host. But why do we require DHCP? Save time. Okay. What else? See, if you have 2 systems, 5 systems, assigning IP addresses individually statically is a fine thing. Okay, 2, 5 system, 10 system, you can do that. But when you are working in the corporate and having 2000 systems, 5000 systems, individually assigning IP address to each and every system is a hectic thing. Plus, there is a chances that you might make up some mistakes. Maybe you will use the same IP twice. Maybe you will skip a IP. Means you will think like, okay, I have assigned 45 IP, but you didn't assign. So you will go with the 46. So the 40 IP number 45 is free. Okay, so like this, you might assign a same IP twice, or you might skip a IP. Plus, you will have trouble creating a record that on which PC you assigned what IP and what is the MAC address of that PC. Okay. So all these things are done by your DHCP. Your DHCP will dynamically assign the IP addresses, plus it will make a record also. It will keep a record of to which system it has assigned what IP. Okay, means to what MAC address it has assigned what IP. This is clear. So used to dynamically assign IP addresses. Used to dynamically assign IP addresses to the client systems. Okay. Now, whenever you just go to your system and whenever you go to your system and set the IP address to automatic to take it from DHCP, there is a 4 message exchange that take place. Okay, 4 messages are exchanged, and those 4 messages are abbreviated as DORA. D-O-R-A. Okay. D-O-R-A. DORA. So DORA. D stands for discover. O stands for offer. R stands for request. Okay, and A stands for acknowledgement. These are the 4 messages. Okay. So if we go across your first message, that is the discover message. Okay. If we come for your discover message. Okay, let me open the slide and see. So DHCP, Dynamic Host Configuration Protocol, is a network management protocol used in the networks to dynamically assign IP address and other network configuration like your default gateway, subnet mask, and DNS. This information is also provided by your DNS server. Then your DHCP is a layer 7 protocol and works on UDP. DHCP works on UDP and uses port number 67 and 68. Okay, 67 for server and 68 for client. Okay. The DHCP server automatically assigns IP address to various network devices. This in turn reduces the work of network administrator to manually assign the IP addresses. And the automatic IP address assignment process undergoes 4 message exchange, and they are abbreviated as DORA, discover, offer, request, and acknowledgement. If we come across the first message, discover message. Okay. So this message is sent by the DHCP client to discover a DHCP server, because whenever you set IP to automatic, your client will try to find out the DHCP server. Okay. So it will try to search. So what it is going to do, it is going to broadcast a DHCP discover message. Then once your server receives this message, your server will make an offer that this is the IP address I have, I can assign you this IP. So this is sent by the DHCP server to lease unique IP address and other parameters needed to the client. So he will send that, okay, I have the free IP address, this one, and this is the subnet mask, this is the default gateway, this is the information. What will happen? The client will receive that. Now the first thing your client is going to do, your client will check whether the same IP is being used in the network. Checking for duplication. How? ZR. So your client will generate a ZR before accepting this IP. Okay, client will send an ZR, will check whether the same IP is being used in the network. If the same IP is not being used in the same network, your client will send a request message. And this request message is just to show the acceptance of the IP address. Your client will say, okay, I accept this IP address. Okay, so please give me all the details. I accept this IP address. Once the server receives this request message, server will see, okay, the client is taking this IP. So server will make an entry that, okay, the client MAC address is this, and to this MAC address, I have assigned this particular IP. And then DHCP server is going to acknowledge the request that, okay, now you can use this IP address. So once these 4 messages have been exchanged, then only your client can use the IP address. Otherwise, it cannot use the IP address. Okay. After all these 4 messages have been exchanged, then only the client will have the IP address. Okay. So first is the discover message. This is the first message generated in the communication process between server and client. This message is generated by the client to host in order, not to, but you can say this is or. Okay, generated by the client, or you can say the host, in order to discover if there is any DHCP server or servers are present in the network or not. Means to look for DHCP server. That is there any DHCP server, or if there are multiple servers, are there any servers? This message is broadcasted. See, all your DHCP messages, the DORA messages, they are all broadcast messages. Why? Because the server doesn't know about client, because client doesn't have an IP address. Okay. So if he has to send the information to the client, it has to be a broadcast. Okay. So this message is broadcasted to all the devices present in the network to find. Clear? Now, once your DHCP server receives this message, the server will respond to the host in this message, in the offer message, specifying the unleashed IP address and other TCP configuration. Like, it will say that, okay, I have next this IP free, and this is the subnet mask default gateway DNS. This message is broadcasted by the server, and if there are more than one DHCP server in your network, there are more than one DHCP server, then both will be making the offer. Your client will accept the first offer that is reaching the client. First come, first serve. So if there are more than one DHCP servers present in the network, then the client host will accept the first DHCP offer message it receives. Okay. Also, a server ID means the server will mention its own IP address, that I am the server who is providing this IP address. Okay. So also a server ID is specified in the packet in order to identify the server, so that the client can later on identify that, okay, this is the server who has provided me. Okay.
Sir, DHCP offer message. DHCP server will advertise single IP address or
single IP address. Only single. Because one host will need one IP address only. Okay. Then the client will send the request message. So when a client receives an offer message, it responds by broadcasting a DHCP request message. The client will produce a ZR in order to find if there is any other host present in the network with the same IP address. If there is no reply by other host, then there is no host with the same TCP configuration in the network. And then the client is going to broadcast this request message to the server showing the acceptance of IP address. That okay, I will accept this IP address. And in this, the client will also mention its client ID, the MAC address. Okay. And then finally, the DHCP acknowledgement. In response to the DHCP request message received, the server will make an entry with the specified MAC address of the client and bind with the IP address offered with the lease time. What is the lease time? Lease time is the duration your client can use the IP address. Like how long the client can use the IP address. After that, the client will have to release the IP and renew the IP. Now the client will have the IP address because the server has acknowledged the request. This is clear? Okay. What is the advantage of your DHCP? So centralized management of IP addresses, ease of adding new clients. So if you add a new client, the client will automatically get the IP address. You don't have to worry about assigning the IP address statically. You don't have to check, okay, what is the next IP I have to assign. Reuse of IP address, reducing the total number of IP addresses required. So if you miss any IP address, or let's say there is an IP right now being used. Okay. For example, if I say CMD and if I say IP config, right now my IP is 100. Sometimes I will get 110 IP. Sometimes I will get some other IP. Why? Because if the particular IP is free, my server is going to assign me randomly. Okay. So what happens? Let's say if a IP is free in the network, your DHCP server will first assign the free IP, then the new IPs. Okay. Simple reconfiguration of the IP address space on the DHCP server without needing to reconfigure each client. What does it mean? Let's say today we are using the 172.16.1.100 and I have 1000 systems in my company. So all are using this network. Okay. Now you are the network admin. Now tomorrow the company says, okay, I want to use the 10.1.1.0 network. Now what? If you do not have DHCP, you'll have to go to the 1000 system and change the IP and everything. Correct? But if you have the DHCP server, just make changes in the DHCP server and the clients will automatically get the IP address. So that's why we say the DHCP help in the simple reconfiguration of the IP address space. Simply change the network. Okay. Configuring the DHCP server, clients will automatically get the IP address. Okay. This is clear. Now we'll see how to configure. Theoretical part is done. Now we'll see how to configure your DHCP server. So we do not require this topology. We will simply take one router, one switch, two PCs. Here we'll be using the network 10.1.1.0/24. And let's say this is your DHCP server. Okay. So on the DHCP server, we'll be making all the configurations and the IP we will be using on the router 10.1.1.1. This is clear. Okay. Just go to the router. CLI. Say no. Enable configuration terminal. Okay. Host name. DHCP. Interface Z0/0. IP address 10.1.1.1 255.255.255.0 and then say no shutdown. Okay. Now what you want to do, you want to create it as a DHCP server. So the commands are very simple. Say IP DHCP pool and give any name. Let's say CCNA. Okay. Then say network and whatever network you want to give. Let's say I want to give here 10.1.1.0 and the subnet mask is 255.255.255.0. Now these clients, to go on the internet, they will need default gateway also. So if you want to assign default gateway also to them, then give the command default router. And what is the default gateway for them? 10.1.1.1. You want to assign DNS server also? Say DNS server. And let's say 8.8.8.8. This is done. Yes, we'll come to the DNS. Next part is DNS only. Okay. Now see, you have given all the information. Okay. Now let's say you want that, okay, your DHCP server should not be assigning the IP address from 1 to 50. Sometimes you want to reserve some IP address so that you can assign them statically. Okay. So what you will do? You will give the command. What command you will give? IP DHCP excluded address. Okay. And from where? 10.1.1.1 till 10.1.1. Let's say 50. So now my DHCP server will assign the IP address from 51. Okay. See, check. Go to the PC0, desktop, IP configuration, and say DHCP. See, IP address is what? 51. This is the subnet mask, default gateway, and DNS. All the information is there. Okay. Now I'll show you the 4 messages. Edit filters, show all none, and we just want to see these. Okay. So I'll go to the PC1, desktop, IP configuration, and DHCP. Message is generated. See what message it is. Do you see here? This is a DHCP discover packet. Correct? Okay. See, it is going for the server and going from the client. So for client, we use port number. For server, which protocol? UDP. Okay. And since the client is not having an IP address and also doesn't know where is the DHCP server, this packet is a broadcast. See, 255.255.255. And MAC address also you can see. Correct? Awesome. So discover message will be delivered everyone, but these are not the servers, so they will discard. This is the DHCP server. Now this will respond. See. So it will respond. See. So this packet, this is the DHCP offer packet. If you open it, okay, right now it is at the layer 2 on the switch, only layer 2 information. But if you go to the outbound PDU detail, see UDP packet, source port is from the server going to the destination client. Okay, what is the DHCP information in this? Do you see what it is saying to the client? That I can give you this IP address. Correct? And also giving its own address that I am your DHCP server. Correct? This is your DNS server information. So like this, your DHCP server will give the IP that this is the free IP, subnet mask, and all this information. This is clear? Okay. So this offer message will reach the client. Now again, these PCs, PC0, PC2, PC3, they did not request for IP, so they will drop this packet.
Sir, when DHCP server reply an offer, it will advertise the default gateway.
Yes, everything will be advertised. Then your client will send what? Request message. See here. This is the incoming packet. So incoming packet was an offer. See. The packet is a DHCP packet. And if you see the inbound packet, this is the DHCP offer. Okay, here it is not telling the, yeah, here it is. The DHCP client received a DHCP offer packet. Now, in reply of this DHCP offer packet, what your client will send? Request. See this one, outgoing. The DHCP client receives an offer packet and construct and send out a request packet. And right now you can just go and check. So far, your client is not having the IP address. So it will send the request packet. These will again drop because they did not request and they are not the server. If you open this packet, the incoming packet was request. Okay. If you see, the DHCP server receives a. Now your DHCP server will send a acknowledgement packet. Okay. And still your PC is not having the IP address. As soon as this acknowledgement packet reaches your PC, see, still it is not having. But as soon as this packet reaches here, now it will have the IP address. Check. This is clear. Any doubt? Okay. So DHCP process is clear.
Yes.
Online people, guys, clear? Not even responding. Okay.
Yes, sir.
Okay. So how we are going to configure DHCP server? You are going to say IP DHCP pool and you'll give any name here. Okay. Then you'll see which network. So for network, you'll give the network ID. And after that, you'll give the subnet mask. If you want to assign default gateway also, you'll give default router and gateway IP. You will give here. Then you'll say DNS server. And here you'll give the DNS server IP. Okay. And if you want to exclude some addresses, you'll give the command IP DHCP. Excluded address. Then start IP and ending IP. Okay, these IPs will be excluded. And this is what DHCP configuration. Here,
Sir, for a DHCP configuration, you have some special servers like or router.
we just did in the router. Okay.
Sir,
Yeah.
how can I configure DHCP for two different networks?
Yes, you can do that.
What will be the commands?
Hmm?
What will be
Create
the
two
commands?
pools.
Create two pools.
Same thing. Just create two pools. Your router will have two interfaces. Correct. So just create two pools and router will start delivering through the two pools. No problem. Okay. You can create even 10, 20, anything you can configure here. Is that clear?